Oh, Jeremy again. Today we're talking about weight and balance. Weight and balance is extremely important because if you're out in weight and balance, you can't have stable flight. If my hand's your helicopter and you have too much weight to the front, center of gravity has to be underneath your rotor blade. So if you have too much weight to the front, it's going to be completely tilted down, causing you to fly forward. Even when you're completely aft cyclic, you won't be able to stop the forward progress. Same thing if you're too much rear center of gravity, you're going to be able to go backwards, but you're not going to be able to go forwards, even in full cyclic forward. So doing your weight and balance before every single flight is extremely important to know that with the gear and with the fuel, with the pilots that you have, that you're going to be inside your CG. This is our sample weight and balance sheet. Why don't you go ahead and pull yours out and you can do the calculations along with me. That way it's a little bit easier for you to see and you get hands-on practice. So I'll give you just a second to do that. Alright, you've got it out. Now this is where we do our actual calculations. On the graph portion of it, this is supplied by the manufacturer and it has some standards that are set in that never change. And then what we put in today is for the actual helicopter itself and things like fuel and how much pilots weigh, that kind of stuff. So our first box up here is empty weight of the helicopter, and today it is 867 pounds. The arm, definition of the arm is how far forward or backwards. Well, how far forward, because everything is measured from the datum plane, which is a made-up. This is our helicopter. The datum plane can be either right at the center, it can be in the middle, it can be at some point out here. Doesn't really matter where it is, but the manufacturer states where it is, and that's where all these calculations come from. So the arm is how far forward center of gravity is. And this one is 103.94. The pilots that we have today, the right seat pilot is 158 pounds, and the left seat pilot is 170 pounds. And then our latitude arm is -0.2. Latitude arm is the same thing as longitude arm. It's just to the sides instead of forward and backwards. It's latitude, left and right. And so the way that we fill out this page is first we take and we multiply the weight by the arm, and that will give us our moment. And so we take 867 and we multiply it by 103.94. That gives us 90116 pounds. And then we do the same thing for the right seat, which gives us 1, 2, 3, 2, 4. And the left seat, 170 times 78, 1, 3, 2, 6, 0. So now we know what our arms are, or our moments are, the long moments, and we're going to get a total of it. So first we need a total of all the weight, and empty weight of the helicopter is with oil and that kind of fluids in it, but not with fuel in it. And we total up the empty weight of the helicopter, the pilot on the right seat, and the pilot on the left seat. And we come up to a total of 1195 pounds. And then what we're going to do is we're going to add our moments together and to get a total moment, a total long moment. And that comes to 115,700. So this is our total long moment. This is our total empty weight. Now we're going to divide the long moment by the empty weight, and that will give us our long empty center of gravity right here by dividing 115,700 by 1,195. So when you do that, we get 96.8. 96.8 is our CG for longitude, so we're going to put that right over here. 96.8. for empty longitude center of gravity. Now we're going to do the exact same thing that we just did for the longitude. We're going to do it right over here for the latitude. So I'm going to give you just 1 second. Again, you multiply this one by this one, this one by this one, this one by this one to get your moments. And then you add up your moments to get a total moment, and you divide the total moment by the total empty weight. So why don't you go ahead and do that real quick first, and we'll see what you get. Good job, that was real quick. I'll go ahead and put my answers in here, and you can check to see if you're right. Minus 173, 1690, minus 1581, minus 64 for the total. And then when we divide minus 64 by 1,195, for our center of gravity, we get 0.05. So what you got? Good job. Take the 0.05 and put it over here, negative 0.05. So this is our center of gravity for empty weight. Let's go ahead and plot the empty weight, and then we'll see what happens when we add fuel. So then we go to graphs that look a lot like these. And as you can see, we have longitude, center of gravity at the bottom, and we have gross weight coming up the side. And then same thing. Here's our 0 point, negative is positive, and here's our same points longitudinally. So 96.8 at 1,195 pounds. So first we'll go to 1,195 pounds. It's right about here. And then 96.8, here's 97, so it's going to be just inside. And where those two meet, we place a little dot. Now we're going to do the same thing for latitude. Latitude is this graph up here. We're going to take the same spot as we got for the longitudinal line and come straight up. And we are negative 0.05. So here's our 0 mark. So negative 0.05 is going to be right about there. So that's how we plot our points. So that's with empty fuel at the very, very end of your flight when you're about to crash because you're about to run out of fuel. So let's see what happens at the very beginning of our flight, because your center of gravity is going to shift on you as you burn fuel down. So down here, as we calculate how much fuel we can take, how much fuel we're going to take. In our case, we're going to take 19 pounds. Remember how much fuel weighs? 6 pounds, exactly right. So when we multiply 19 pounds by 6, we get 114 pounds for our fuel. Again, we multiply 114 by our longitudinal arm, and that gives us 1, 2, 3, 8, 0. We're going to do the exact same thing for our latitudinal arm. 114 times negative 11, which gives us a negative 1, 2, 5, 4. Then we got to see what the total weight is, including our fuel. So we add our empty total weight plus our fuel weight, and that gives us 1,309. And then what our total long moment is, we add our empty total moment with our fuel moment, and that gives us 1,280,80. And then just like we did up here, we divide our long moment with our total fuel, total weight, including fuel, and that gives us 97.8, which we put right up here for center of gravity full tanks. And then we're going to do the exact same thing over here for the long moment side. We add the two negatives together, and that gives us a negative 1,318. We divide it by the total fuel weight, including the helicopter, and that gives us a negative 1.0. Negative 1.0. Now we're going to go ahead and plot that to make sure that we're inside of CG. So 97.8 at 1,309 pounds. So right up by our top, 97.8 at 1,390 pounds is going to be right up here somewhere. And so this line shows us how much our center of gravity is going to shift between having fuel and having no fuel. Let's go ahead and plot the latitudinal moment, or center of gravity, -1. So we go from right where this dot is, up, 0 is right there, -1 is right about here. So as you can see, it's going to shift. When you're burning fuel, the center of gravity is going to shift towards the center, and it's going to shift backwards. I guess it's going to shift towards the left. Shift backwards. Now, if when we're plotting this, we get something like, let's say 95.1, and we try to plot it, we can plot it at the empty weight, and it's out here. Or if we're plotting something and the dot's up here, we can't go fly because we're not going to be able to control the helicopter when it's out of center of gravity. Same thing here. If we have one of our dots down here, if we have one of our dots way up here, we're out of center of gravity and you can't go fly. You have to figure out how to shift some weights around or go with less fuel or something else. So that's how you go over your charts. Checking your weight and balance. It's pretty intense process, but you get it down and you can go through it really quick and make sure that everything's safe. So that's weight and balance, and this example is for R22. Have a great day.